Today, we are going to introduce another follow-up questions based on Lee Code 22 generate parentheses. So recall last time we have this problem. This problem only have an input number of n, and then we're going to generate all the possible solution with the valid form of parentheses like this. So today we are going to solve another problem based on these questions. So instead of having only the brackets, the regular brackets, we may have pointy brackets and curly brackets. And then the input of this problem is L and M and N. It represent different types of brackets in this question. So let's see how we can solve this problem. So let's do a quick recap of what we have done last time. So we are using DFS solution actually with constraints, which means the left brackets has a constraint. It has to be less than the total number of n. And then the right brackets must less than the total number of left in this level. And then if this condition is met, then we add our the specific characters to our string builder called prefix. And then the base case, which means when it arrives, the number, this number left plus right equals to 2n, then we collect the possible answers at this level. But let's see how can we solve this problem. So now we have different types of brackets. I think we can reuse the same idea we have last time. So our input signature will be something like this. The answer will be the same. We are going to return a list of string. We can use the same name of the same method name, L and M and N. So our main, let's analyze these questions. So, and then this is more like a follow-up questions, and then we may have different types. So as you may seen that maybe the next follow-up question is that we may add priorities to different parentheses, but let's solve this for now. So the priority doesn't really matter. Say if we have L equals to 1 and M equals to 1 and N equals to 0. So which means we can do something like this and something like this or this. And maybe the other way around this. So let's keep it simple. So instead of having a single if here, I think we need to somehow generalize the problem a little bit more. We could definitely create an array to collect all the possible answers here. And I think the biggest difficult point is here. So we need to match each open brackets with a closing brackets. So in order to resolve this problem, we probably need a data structure that can record the last brackets we added, and then based on the last bracket we added, we find the correspond closing brackets that will match it. Then we add it to our prefix string builder. So how can we do this? Yep, we probably need so we probably need a stack to to keep tracking of the last bracket we add, and then we also need to need a collection of the brackets. Yeah, because the input of our helper method will no longer be only one integer. We have multiple integers. And then so if we have another one, let's say K or P and Q, then the problem will become much complicated. So let's just use an array to collect all the possible left so far. So we need an array to track the left brackets, track different types of left brackets. And then at the same time, we need another array to track the right brackets. Okay. And then so we give them the corresponding index. Index matters. Corresponding index, for example, let's create an index of the first one, left, and then this one and this one. And then our right array will be the same types of bracket. Something like this. Okay, so we should take this as a reference number. And then we need an array to also need to track the current number we add so far. So originally it could be 0, 0, 0. So if we have, for example, if this number is 2, that means we already add 2 pointy brackets, opened brackets at this point. Okay. And then, yeah, so right before we try to add this, so we can build up our logic here. So collection of the brackets. Yes, I think we need another array for the total number of brackets. So left and right. Okay, let's see how we code this. Yeah, I think one point is not quite clear is how we construct this this logic based on the previous questions. So for the left total, for example, we have total, we should have, according to 1, 1, 0. The left total will be 1, 1, 0. At most, it can add 1 left brackets of the first type and 1 brackets of the second type. So the right will be the same. So this will be our starting point. So yeah, so everything should be based on our previous answer. Okay, let's see how we can code it with our helper method. I think nothing changed here. So the same to Java. But the input of the helper method could be different. So our input should be left total and right total. And also we need to keep tracking of the left brackets that's add so far, and then the right brackets. So this basically these two arrays to keep tracking of the current status, and then whether or not we should add the open brackets or the closed brackets at this specific node in our recursion tree. So of course we need a string builder at this point, prefix, and then we need to have a stack. The interface we use should be a stack of characters. And then we also need a list of integer. Oh, sorry, a list of string to keep tracking of all the final answers. So in this case, we should have our base case as the added left in the first index plus added right at the second first index should be equals to what? Should be equals to the left total and right total. So this is the only one conditions we need, but we also need to have the other two, right? Because we have 3 different kinds of brackets. Oops. Actually, we can turn this into a loop or something, but we only have 3 different kinds, so I just keep things simple. So if we have this base case, then we are going to add our string builder prefix to the string. And then we can return. Let's see how our recursive writes. So we can definitely write something like if added left 1 is less than our left total, and we do something, right? Oops. And definitely we are going to add our brackets in, and the current state of the left array needs to be increased, and our stack needs to add this in. So we need to call itself again using left total, right total, left, right, our prefix and stack, and our result. At the same time, we need to backtrack of the states. So we need to return it to the original state as if we didn't touch anything after we call the DFS. So we need to remove, it's called delete at, delete chop at the last character, and then do nothing. We need to call first to remove the top element. We can definitely do the same thing for the second elements in the array and the third element in the array. But I want to make things simple. Let's just write a for loop. It's equals to less than length, and we add. So we make sure that the same idea is going to do it 3 times. And then we can turn this as an I. However, we cannot add the same element each time. So we probably need a global value that's called as a track of all the characters. That's called left map. Should be, yeah, the order matters at this time. 20 brackets and curly brackets. Something for this. So yep, so we only need to add left map and the I element. Same idea here. So how are we going to add the closing brackets? So I think that's also follow the same idea here. So let's look through it 3 times. And then you definitely need to do the checking. That's we check the top of the stack. If that's match what we are adding it in here, then we can add the corresponding closing brackets. And we also need to have an empty checking of the stack. Otherwise, we will have a null pointer exception. So we need to make sure that the stack is not empty. Then we can enter into the condition. So the same thing applies to this one. We need to be really careful about what we're going to add and the index of each statement. So we are adding J here, and then actually we're adding it the right map, and then we're adding J here. Okay. At this point, we shouldn't offer anything in our stack. And instead, we are going to pop. We are going to pull the first element because we find a match. So this should be the correct sequence. However, we need to say add the right in J index plus, and then we call ourselves again. And then we remove it, and then return to the original state, and then add it back. We need to be really careful about what we're going to add. We are going to add the left brackets here. Okay, I think this logic makes sense to me. So the next step will be our main function, what we are going to construct here. So assuming that all the number we enter are greater than or equals to 0, and then we should at least have, if the summation of each single of them should be greater than 0, otherwise there's no need to go through the logic here. So yeah, we need to construct our left total and our right total. And also we need to construct our array to collect the status of each changes. It should be 0 at the initialization state. Okay, so what else we need? We need a string builder. And we need a stack. So we are going to use an array deck to implement it. And then we only use it one side, which is the first hat. And then also we need a list of string to collect all the answers. So let's use array list. So in this case, we can add every single one of them here. And prefix and stack and the result. And after that, we return our result. That's the main logic and the main algorithm we're going to introduce here. So I don't think you can find the problem in LeetCode. So let's just run through in the IDE here. So I think I already write it. So let's remove them. And let's verify what we just wrote here. Apparently, we need to consider this is a class. So we want to make this private static final, because we are not going to change the value of our parentheses map here. So let's make it final. So let's take a look at our logic once again. Let's make sure everything is good. Generate parentheses, value parentheses. Okay. So let's say if we have 1, 1, 1, what will be the output? Oh, we have an error here. Let's check. Unresolved compile error. Equals. Still be mistake. All right, so let's see our answer. Let's check if every single one of them is valid. It looks like we have the answer here. Let's change it to 2. Okay. All right, I think that's all we have here this time.